This problem is related to the order of a reaction, and a reaction has been given, and this reaction is 2 times hydrogen gas plus 2 times NO gas, and this gives you nitrogen gas plus 2 molecules of water gas. And the mechanism of this reaction has been given, so which involves 3 steps, and the first is, this step is fast step, this is a slower step, and this again fast reaction or fast step. Then you have to find what is the order of this reaction. So let us try to solve this problem. So this is the mechanism that has been given for this reaction. Now you have to first find out which step is the slowest step or rate determining step. So in this case, the second step is the slowest step, and hence this step is the rate determining step of this reaction. So as you know, slowest step is the rate determining step. So rate of reaction will depend upon this slowest step. Now in this case, there are 2 molecules. This is a bimolecular reaction. So I have coefficient 1 here, and this is also coefficient 1 here. So now I can write rate of reaction is simply concentration of this multiplied by concentration of this, because the coefficient is 1 and here also coefficient is 1. And you have to also write some constant. Let us say constant is given here, and this is the constant K2, that is the rate constant. So rate of reaction can be given by this expression. But now N2O2, this N2O2 that is coming from the previous step, and this is used in this step. So this is a basically intermediate. If you see the overall reaction, in the overall reaction N2O2 does not appear. This means this is an intermediate, and we have to remove this from the rate expression. So N2O2 is an intermediate. So rate for this reaction is given by this, that is rate is equals to K2 times N2O2 concentration times concentration of hydrogen gas. Now as I said earlier, intermediate is something that forms in one step and it is used in the next step. So how we find concentration of N2O2, that is concentration of that is intermediate. Now I will use this step, that is fast equilibrium step. Now because this N2O2 is used, it forms and it used, this means at any point of time its concentration is constant. So this means rate of forward reaction is equals to rate of backward reaction, because it is not building up or it is not used up, or you can say it is built up at the same amount and it is used as at the same amount. So rate of forward reaction is equals to rate of reverse reaction. That is important point here, because N2O2 is an intermediate, so we can write this expression. So what is forward reaction, rate of forward reaction? This will be K1 times concentration of NO raised to the power 2. So this is K1 times concentration of NO raised to the power 2. What is backward reaction rate? That is concentration of N2O2 times backward rate constant, that is K sub minus 1. Now from here I can calculate the concentration of N2O2. So if you take this is K1 divided by K minus 1 or K sub minus 1, and this is equals to concentration of N2O2 divided by concentration of NO square. So concentration of N2O2 you can write, this will be here and this term will go this side, so you can write concentration of N2O2. Now you have two equations, equation 1 and equation 2. Basically you can plug the value of this, that is concentration of N2O2 in equation 1, and then you can write expression for rate. So this is the expression for rate. Now in this case NO has a power of 2 and H2 has a power of 1. So what is the order of this reaction? So this is 2 plus 1, so the order of this reaction is 3. So this is a third order reaction. So I hope you enjoyed this video, and if you enjoy these videos, please share with your friends, like on my channel, subscribe to my channel, and I will see you in the next video. Thank you.